Welcome to The Explainer. Today, we're diving into Google DeepMind. We're going to look at how this AI lab went from mastering an ancient board game to tackling some of the biggest scientific challenges of our time. It's quite a story.
You know, when you hear about these super advanced AI labs, it's easy for your mind to jump straight to science fiction, right? I mean, when DeepMind first started making headlines, people on Reddit were already joking about Skynet and building a self-aware robot army.
But the reality of what Google DeepMind is really up to, well, it's way less scary and honestly a lot more fascinating. They're not building robots, they're trying to build intelligence itself.
So to really get what DeepMind is all about, we got to start with the core tech that powers it all, machine learning. And this is a totally different way of teaching computers how to figure things out.
Okay, think about it like this. A regular computer, it's kind of like a dictionary. It's super fast, super accurate, but it needs an exact entry for everything. If you haven't programmed it for a specific situation, it's just lost. But machine learning is all about associative learning. It lets a computer start to infer things, to connect ideas, and even generalize from experience, kind of like we do. So to prove this new approach could actually work, the founders of DeepMind needed a challenge. They chose a proving ground that had stumped computer scientists for decades. I mean, the perfect arena to really push the limits of this new kind of learning. And what did they choose? The ancient game of Go. Now, this isn't like chess, which is all about power and raw calculation. Go is a game of deep strategy, intuition, and controlling territory. For a long time, people thought of Go as this fortress of human intelligence. And here's why that was such a big deal. The number of possible moves on a Go board, it's astronomical. It's bigger than the number of atoms in the known universe. So you can't just brute force your way to a win. It's literally impossible.
And then, in March of 2016, it happened. DeepMind's AI, called AlphaGo, did something that a lot of experts thought was just impossible. And get this, it did it about a decade ahead of schedule.
AlphaGo went up against the world's top Go player, Lisa Dole, and beat him in a pretty stunning 4-1 victory. The machine had somehow learned the intuition of the game. It was coming up with these wild, creative strategies that even the human grandmasters had never seen before.
But here's the thing. For DeepMind, just winning the game wasn't the end goal. That was just a milestone, right? The real prize was to keep pushing the technology, to see if they could make it learn even better, even more efficiently.
And their systems evolved fast. So the first AlphaGo, it learned by studying tons of human games. But its successor, AlphaZero, started with nothing. It just learned by playing against itself over and over until it was better than any human at Go, chess, and shogi. And then MuZero took it to a whole other level. It learned to master games without even being told the rules. Just think about that for a second.
Okay, so after basically conquering the world of games, DeepMind turned this incredibly powerful learning technology towards some of the biggest, hairiest, unsolved problems in science.
And one of their biggest breakthroughs is a program called AlphaFold. Now, for like 50 years, scientists have been banging their heads against something called the protein folding problem, basically figuring out the complex 3D shapes of proteins. Well, AlphaFold solved it. It can predict these structures with an accuracy that's pretty much on par with doing it in a real-world lab.
And this is a huge deal. It's not just some academic puzzle. Understanding a protein shape is absolutely crucial for creating new drugs and figuring out diseases. This tech is already shaking up the world of biology, and we're seeing similar AI ideas being tested for actual use in hospitals and clinics. For example, there's a system called Codoke. It's built to help doctors and AI work together. So you have a medical image, the AI gives its opinion, the doctor gives theirs, and Codoke is smart enough to learn when to trust the AI's call and when it's better to go with a human expert.
And the results are really promising. In one test with a big mammography dataset, this kind of human-AI team-up cut down on false positives by an amazing 25%. And it did that without missing any real cases. That's a game changer.
So all these fundamental breakthroughs, this whole new way of learning, they've basically paved the way for the next wave of AI. The generative tools that we're all hearing about in the news every single day.
And yeah, DeepMind is the engine behind a lot of Google's big generative models. We're talking about everything from the super powerful do-it-all Gemini model, all the way to specialized tools that can whip up images from just a text description, create really high-quality video, and even compose brand new music. But all of this stuff,
All this incredible work, from mastering games to solving protein folding to creating art, it's all building towards one single, ultimate, and super ambitious goal.
And that goal is something called artificial general intelligence, or AGI. Now, this isn't an AI that's just good at one thing, like playing a game. We're talking about an AI that could reason, learn, and adapt with the same kind of flexibility as a human mind, across, well, pretty much any task you can think of.
And according to the CEO and co-founder of DeepMind, Demis Hassabis, this isn't just some science fiction dream for the distant future. He actually believes AGI could be a reality within the next 5 to 10 years.
So that leaves us with a really big thought. What you should take away from this is not just the incredible stuff AI has already done, but the mind-blowing potential of what it could do next. I mean, if AI can master games and solve science, what happens when it can solve everything? The impact could be completely transformative. And that journey, from the Go board to AGI, it is absolutely well underway.